So I want to start off by showing you something quite important. I want to introduce you to one of the most efficient problem solvers on the planet. It is a single-celled blob of goo called Physarum polycephalum. It's otherwise known as slime mold, which means whoever's doing the branding or the PR is not doing a good job for them. And what happened a few years ago is some scientists in Japan put this slime mold into some Petri dishes. And they arranged food in the shape of all of the cities of Tokyo. And so as this mold grew to try and find that food, which it's particularly good at, what happened is it created this web. And this web connected all of the food together in the most efficient way the mold could find. And what they sort of then found out is when they looked at the connections that it had made, it was an almost exact replica of the Tokyo subway system. So this mold had created its own most efficient path, which was pretty much what we, over the last 120 years, had managed to do as humans. You might be wondering why I'm talking about mold in terms of AI. This is exactly what we need to look at AI as being. AI does not think, it does not understand, it does not have ideas, it has no concept of words or language in the way that we expect it to. It is just a mold. It's doing exactly what it's been trained to do. In the case of mold, it's finding food. It's very good at that. In the case of AI, it's just predicting the next word. When we talk about AI, we need to think more than just the LLMs that we look at, the ChatGPTs, the Gemini, the Claude. It's actually all about what is the intelligence? What do we think of when we think of artificial intelligence? And therefore, how can we look at AI in our jobs? So artificial intelligence is obviously something we hear a lot about. I want to look at it in terms of the practical, the sort of ways that we already use it, what we can do in any industry, not just the things that we normally expect in terms of tech, coding, that kind of thing. Because it is a really interesting turning point, as we saw in the panel, where this is potentially one of the biggest inventions humans are ever going to have. It's going to have a massive impact on not just the way that we do things, but the way that we live, even outside of work as well. To the point where even the CEO of Google, Sundar Pichai, said it could be more profound than fire or even electricity. And really, to understand why he said that, we need to look at things beyond what we hear in sort of the news. We hear a lot about AI is going to end the world, no one's going to have any jobs, and it's all going to be awful. Or we hear AI is going to be great, it's going to make everyone completely rich, no one's going to have to do any work, it's going to solve everything for us. It's not actually either of those extremes. It's somewhere in the middle. There is more nuance to it. And we need to dig into not just, is it going to kill us, is it going to make the world better, but what does it actually mean? What is the practical use case for AI? So let's define it first. Artificial intelligence is just any computer system that attempts to perform a task that normally needs humans, normally needs a human intelligence. So it's not just the kinds of things that we see in ChatGPT and Claude and Gemini. This is a very specific type of AI that's obviously changed things and is really accelerating the sort of language side of things. But AI is everywhere, and it has been for a very, very long time. It is what powers Google Maps, getting here today, the train line, if you book tickets, all of that uses AI in a very specific way. It shows you all of the ads, so algorithms, TikTok, Instagram, all of that is AI. It's just that people haven't seen it as being a standalone thing before, and actually we need to look at it as the technology, not the final product. If you've ever used Spotify DJ as well, this was a massive sort of combination of 4 or 5 different AI systems that all came together into a final thing. If you've used DJ at all, it's all AI. And that's a really interesting way of looking at, it's not just, can it write my essay, can it write my homework for me? You can do really, really cool things with AI that aren't just writing text. And all of this is thanks to something called machine learning. So I'm sure many of you have heard about machine learning before. It is just the concept of training computers to be good at something. And that thing can be anything. Perfect example is chess. So chess was one of the really early examples of machine learning where we tried to train a computer by saying, winning is better than losing in a chess game. Here, watch hundreds and hundreds of thousands of different games of chess and try and figure out what the next best move to make would be from all of these different things. And this is not new AI. There's a system called Deep Blue that was invented by IBM. And they trained it to play chess by doing this training process, this machine learning. And it managed to beat the world chess champion in 1997. So this is way before we start to see Spotify, DJ, algorithms, Instagram. This is before the turn of the millennium bug that some of you may have heard about before. And it's this ability to learn things that is really the power behind modern AI and machine learning. We can train it to do all sorts of different tasks for us if we have that data set to start with. And as computers have gotten more and more powerful, especially since sort of 1997, way, way less there than we have now. And this sort of scaling up the training process is what means that we can do ChatGPT, we can do Gemini, we can do Claude. Thanks to these things. These are data centers. So this is, imagine the computer in your house times 20 million, just massive warehouses full of computers, all trying to do this training process, trying to do things repeatedly and trying to make things better in terms of that prediction, that probability. So we've let ChatGPT read more text than any human alive could ever read, to the point where we're actually starting to run out of stuff for it to read because it's read everything that humans have ever produced. So we're creating new stuff with AI to then train more AI. So there's lots of interesting things that we have to do once we get to this scale to actually still be able to accelerate it. And it's one of the reasons that potentially AI might not be as scary or might not accelerate as fast in the future, because if we reach the limit of what humans have done, we're starting to give it worse and worse stuff to train on in future. So AI isn't anything new. Why are we talking about it so much now? Well, LLMs as a very specific type of AI are incredibly powerful. That's something that humans have always sought, well, not always, most people have thought that they would never be able to do. You might have heard of something called the Turing test, which was being able to test whether you were talking to a human or a computer. That's gone out the window. That's no longer a good measure because no one these days can tell whether something is AI text or whether it's human text. Anything you see about like, oh, they always use M dashes, people use those too. So it's not a good predictor. So these intelligent advanced systems that we have now are also then available really generally. So we have on our phones, you can have Gemini for free, and it's one of the most advanced systems ever created. That's such a huge shift in the way that technology is distributed and how people can access it. And that's why it's making such a huge impact on our daily lives. And some people are quite worried about that. We've seen in movies, we've seen Ultron, Skynet, Terminator, all of those kinds of things. These are the scary visions that we've had in the past. And actually what people are arguably more scared about these days is that all of these movies have the don't give it access to the internet. And we've gone, yeah, here's the internet, immediately. And this is what's quite scary, is that it's not something that's controlled centrally. We don't have good regulation from government. It is potentially quite a dangerous thing for us to be doing, is just rampantly trying to get there. So we need you guys in the future of AI sort of technology and research to be aware of those kind of concerns. And also, if you're not using it for AI research, you might be using it for something else in any industry. It's still going to have these kind of ethical risks. And it's worth noting that it doesn't have to sort of go all Terminator and decide it wants to end the world. We can do that ourselves accidentally. So say you take a really advanced AI system and you say, I want to reduce CO2 emissions to save the environment. It's a good start, means well. So what the AI system might then do is try and identify the source of CO2. Where's it all coming from? And if you say, I want to reduce where it's coming from, well, it's coming from humans. So the most efficient way to stop carbon emissions is just get rid of all those carbon-emitting humans. That's not it doing something wrong. It's doing exactly what we've told it to, but it's the context. It's how we ask it, how we understand that technology and how it's working that stops it from accidentally ending the world. So as it becomes more prevalent, we're going to have people working in all sorts of different industries, especially digital, to try and stop this kind of thing happening. So you might see safety filters. They say, oh, it's great. We've trained it to not tell you how to make bombs, is a perfect example. And then someone will write a poem about a grandma who tells them a bedtime story about how to make a bomb. And it goes, oh, here you go. Here's a story to how to make a bomb because my grandma told me this story once. It's very, very, very limited what we can do at the moment in terms of filtering. So digital is a really exciting place to be to try and stop that stuff happening. So that's all the stuff that could go wrong. Quite scary. But what could go right? I think we've heard all of these big stories about sort of layoffs and productivity going out the window and us not knowing what to do with jobs. There is always going to be a space for humans. And actually, it's not that AI necessarily is going to take people's jobs. It's a classic aphorism that some people might have heard. It's people using AI that are likely to be taking jobs. Not knowing how to use it, how it works, how to make the most of it is going to be one of the bigger risks to your career than the technology itself. And so to explain that concept, I want to talk to you a little bit about a story. So this is a real story, and I want you to imagine you're in Tokyo and it's lunchtime. Quite hungry, you want to go and get something to eat, so you go to a bakery. And in the bakery, there are two different sort of areas. You've got your shelves with your prepackaged food. So you've got a donut in a box with a label on it, and it's all sort of packaged away, and then you've got a fresh display, sort of the warm aroma of croissants and whatever pies are there, and it all is really, really appealing. And we find this in marketing, and we do that research. Actually, it's 3 times more likely to sell the exact same product if it's unpackaged and looks like it's in a nice display. In Tokyo, that was quite a problem because then it's not labeled, doesn't have a thing to scan. All of your cashiers are going to have to work out, okay, how much is the croissant, how much is the pie? Remember that, wrap it in something else. It's quite unhygienic. So this is obviously a challenge. And I want you to imagine that instead of doing all of that, you take your unpackaged, your unlabeled food up to the checkout counter, and there's a little glowing square. And you put your food down on there, and a little overhead projector pops up. And you see some green lines and dots appear, and then up pops exactly how much it costs and exactly what it is in a couple of seconds. That system is real and was deployed in Japan, and it's called Bakery Scan. It was invented by a guy called Hisashi Shanbei, and he basically was like, okay, this is a massive problem. We can use AI, machine learning, and machine vision is what this is generally called as a technology, to do that for us. So we can get the 3 times more likely to sell, but then also get rid of some of the problems. Now this was brilliant. This was a really, really successful solution. They deployed it all across Japan to the point where it made it onto the news. People saw it and were like, oh my God, this is amazing. One guy in particular was working at a medical research center on the other side of Japan. He saw the news segment, he saw the machine vision, he was like, you know what? Under a microscope, cancer cells really look like bread. And so what he did is that he looked at the training data and said, well, if I just replace all of this training data of this is a croissant, this is a pie, this is a sandwich, with this is a cancerous cell, this is not a cancerous cell, actually he could train it to be as efficient as it was at detecting bread, but at detecting cancer. And so that system saw, I think, 20 examples of something and became 95% accurate. And so this has completely automated the way that we can detect cancer in the systems that we use in hospitals. And Japan is sort of leading the way in terms of medical research. But this is an AI system powered by a human intervention and that human connection and creativity. So it's that blend of the technology and the humans together that has let us do this. And actually, we've deployed a similar system recently. You might have heard about this from Google. They have a DeepMind team who work on this sort of AI research. And AlphaFold was their technology that tried to use the similar sort of machine learning to predict the structure of complex proteins. Now, this is something that is incredibly difficult to do because they're so complicated, they're so small, and there's so much data involved. I think we'd done like 3 proteins that we'd fully mapped out by 2005. This has now predicted every protein known to science. So this is a massive acceleration in the kind of medical research area and what we're able to do at scale and at speed. And so it's looking at AI as the tool. It's not the solution on its own. It's a technology and a way of getting to that final destination. But you guys are going to be the people deciding what that destination is, how to get there, having those creative ideas on how to apply it. And so that's why it's going to be important to your jobs moving forwards. And to give you a sense of the sort of the scale of data and the scale of power that we're working at now, I want to do a little sort of thought problem. So let's imagine you guys are really good at maths. You can do adding or subtracting in a single second. Doesn't matter what the calculation is. It takes you a second to calculate something. If you wanted to solve 1 million maths problems, it's going to take you 11.5 days. Sounds like a lot. If you wanted to do 1 billion maths problems, change that 4 times, but it still wants to be a B. So 1 million on the top, 11.5 days. Billion on the bottom, 32 years. So that's the scale between 1 million and 1 billion. So you've solved 1 billion maths problems in 32 years. Now imagine you can do all of those in a single second. So you can do everything that took you 32 years to do in a single second. How long do you think it's going to take to do the amount of computation that ChatGPT training requires? Any obvious guesses? No? I've done it already. It's 100 million years to do just ChatGPT. And this is getting faster and faster. This is an old version of ChatGPT. The newer ones are sort of 3-4 times this scale. If you started 100 million years ago, you'd be doing maths next to this guy. And you still wouldn't be getting the same amount as what training ChatGPT takes. So these are massive, massive amounts of data processed incredibly quickly. It was, yes. And I did check what it was spelling out on the calculator because of the amount of photos of calculators that say something rude. But yeah, so this is a massive acceleration in our processing capability and our ability to do things that maybe we think of as being difficult for humans, but it's that unique capability to process enormous amounts of data very, very fast. And this kind of processing is really useful for the obvious stuff. So physics, the kind of processing we see from Gemini DeepThink is solving maths problems that have been a problem for 70 or 80 years, that no human has been able to come up with a solution to because they haven't been able to work as fast as AI can. Coding, something like 50, 60% of all of the code that Google writes now is done by AI. And it's actually software engineers deciding what code they want to do at a more abstracted level that are really driving that forwards. And then content as well. We see, I think, more content being created by AI than humans on the internet now. It's over 50%, which is obviously a huge change in sort of that paradigm of what are you going to do on the internet to produce content that people want to read? Is it just going to be AI generated, or is it something that you can offer authentically as a human that has inherent value? What can you do to sort of accelerate not just the capability to do something really, really fast, but to actually offer something different? Because AI is predicting things that are the same because it's based on all that training data. The CEO of NVIDIA, Jensen Huang, has said if he were a student today, the first thing he would do is learn AI, because this capability and this technology is going to be something that underpins so many different industries. It doesn't really matter what you're going to do in the future. AI will be part of life, because it already has been, as we've seen, but it will just get faster. It will get more embedded into the ways that we do everything. And I think in the panel we're talking about it, but if you're doing a degree, you're not necessarily always doing something that's specifically chemistry or specifically physics. You might be writing a paper, doing research. All of those kinds of things have ways that we can deploy AI that are still going to be powerful and useful. And to give you a sense of the sort of the speed that we're working at and acceleration, I want you to look at this. So this is actually already out of date. It sort of proves my point for me. But this is the ArcAGI test. So when we're doing AI, we want to measure how good it is at doing certain things. That's quite difficult, so we invent these tests for them to do. It's called benchmarking. And so the ArcAGI test is do something that's not in your training data, answer a question. And another one that people call it is a humanities last exam. It's another benchmark. But the goal is to see how good we are with AI at answering these new novel questions and applying that training to something from scratch. You can see it took like 5 years, really, to get from 0 to 5% success rate on this exam. You're not going to pass at 5%. It took us about 6 months to reach the level that humans can do this exam, which is about 85%. And we're actually 87% with O3 tuned. The newer ones are getting to 90, 95% success rate on this. And it's that curve, that 6-month acceleration, that is really why we're starting to see AI become such a hot topic. Even the news is starting to pick it up as something that everyone's going to be involved in and everyone's going to care about. Because it is becoming a part of everyday workplaces. I mean, some of you guys are using it, I'm sure, from the homework side of things, but if you're working like we do in a creative agency, it is just part of life now. It's so embedded into everything that we see that we need to know how to use it in a way that is beneficial for us, and as we pointed out earlier, ethically, because that's really important as well. It's routine tasks, the automation of daily stuff that we work on, doing things on a bigger scale than maybe we could do before with a team of 2 or 3 people, for example. We can filter and process data really, really quickly with it, and then do predictive AI models. So not just looking at what we've done in the past, but if we can train it to do things that we're particularly good at as humans, we can then deploy that to do stuff that maybe we don't want to do, the boring bits, and we get to focus on the exciting stuff. And the careers that we see in digital especially are going to look completely different in 10 years' time. I think it's a classic thing that what you're trained for in school isn't actually the workplace that you work into, it's the one where the people who are teaching you were involved in. AI has really shaken that up, and actually we're starting to see even the people in the industry you're trying to move into are learning. They're going back to school to try and redevelop and engineer those skills. Prediction from the World Economic Forum, which again, sort of out of date now, I think they're saying 50, 60% increase already. This is in the next 2 years. So that 40%, 50% increase, half of that is just finding people who have these skills and this knowledge and this understanding about AI. And this is the specialist roles. We're actually going to see a real big shift in terms of people being able to apply it. Because the training, again, becomes increasingly automated. We start to see that like Google, Meta, OpenAI, those are the people who are really leading the way. And actually, it's an incredibly successful business to move into. If you're looking at sort of machine learning, specialisms, coding, that kind of thing, that is some of the most valuable work that you can do in the modern climate, to the point where Google were offering people $500,000 bonuses to not leave. Not to do any new work, not to do anything, just to not go somewhere else. And I think £2 million salaries going on in the US at the moment for Facebook, Meta, because they're just fighting for the sort of 10 or 15 people who know exactly what they want to do. So it is a really, really big growth area, and certainly something to look at. But it's not the only area. We see digital marketing being a huge area of growth. We see digital publishing, content creation, entrepreneurial skills. All of these things are really, really valuable. And in conjunction with AI, we're actually lowering that floor to getting involved and building something from scratch. And this is all partnership with AI. It's nothing that's just the AI by itself. It needs these humans and these engines of creativity to be useful and be powerful. So it's that creativity, that problem solving, the innovation, the automation, all of that stuff that comes into being able to do really cool stuff with it. So this is one of my favorite stories about AI, and this is from last year. So there were some university students who basically wanted to compete in a competition. And this competition talks about the Herculaneum Scrolls. Presumably none of you heard about it because it's quite niche, but you might have heard about Pompeii. I don't know if anyone's been to Pompeii, maybe. But yeah, Mount Vesuvius was a massive volcanic explosion in sort of the Roman times, and that lava wiped everything out. Basically, the whole village got covered in ash. You can still see the plaster casts of the people who were there at that time have been solidified. What was also solidified was this library. It was about 800 scrolls that we have at the moment that were completely charred. This is basically just charcoal at this point rather than actual scrolls. This is the only known library we have from that time because everything normally rots, paper normally rots. But this is charcoal, so this has stayed around. Problem is, I mean, they tried it in the 1800s, opening this scroll just falls apart. It's completely dead, it's just charcoal. The university students last year decided to use AI as part of this competition to scan through each of these, and they haven't successfully done all of them yet, but basically to use AI to virtually unwrap them. So they made a 3D model of exactly how it was all written, all of the sort of traces of ink that had been burned away, and then using AI, they unrolled it into scrolls that could then be read and translated. And actually what we found so far is there's some new sort of philosophy that we've discovered, how people lived at the time, all of this written down knowledge that we never would have had access to before. And this is within sort of 8-9 months of us now. So this is happening at university where you guys are potentially headed already. And it's these people using it as a tool to do things that we've never been able to do before. It's quite exciting. And I want to talk a little bit about the fact that AI isn't good at everything. We heard earlier it's not great at doing image and video. Cat videos does seem to be most of the internet anyway, so it's particularly good for that. But it's the creativity, it's the coming up with something new that it actually struggles with quite a lot, because we're training in the sort of 7 or 8 times on the same data to create something like ChatGPT. That's only going to predict the stuff that is in that training data. It's doing that probability. It's saying what's the next most likely word. Actually, creativity is not necessarily about saying what's the next most likely. It's about thinking about unlikely things. How do we do things that are new? How do we explain things in a way that maybe makes more sense to us, but no one's ever done before? And this is sort of true for the rest of the stories that I've told you as well, is the bakery scan. It was a guy thinking, oh, I can apply this somewhere completely unexpected that gives us those benefits. So I don't want you to be too scared about AI is going to come and take my job, it's going to replace everything that we do. It's about how do you reframe what that job actually looks like? What is the essence of being successful in a career that maybe historically has done a lot of the data and the grunt work? What does that mean for your future? How can you be the sort of the leaders, the directors, the orchestrators of that? Perfect example of this is Margaret Hamilton. So she invented the term software engineering, and she was involved in the Apollo 11 project that sent Americans to the moon. And what you see stood next to her is all of the code that she wrote to power the computer that was on the Apollo 11 by hand, because they didn't have computers back in those days. And so she, I mean, it's taller than her, and that's not all of it. She wrote all of this out by hand as code that they could put into this computer system. And it was the same company, actually, that we saw with Deep Blue, is IBM back in the day, created these computer systems. But about 4 or 5 years after this, these computer systems have started to become so good at this calculation that the jobs for the people who were called computers, that was the job role that they had, was almost entirely replaced by the computers. But most of the team on the Apollo 11 project then became the people coding the computers because they had the skills, they understood the tech and how it worked. Their role changed, but they didn't necessarily lose it. They were still working, they were still doing the same work. And we saw a similar thing with machine sort of automation, especially in the US, being done by robots. A lot of the people who are successful in those industries came from the background of doing the work themselves because they understood how to fix, how to repair, how to code these machines. And it's those kind of adaptations that we need to look at in terms of the careers, the jobs of the future. So know the limits of the tools that you work with. Learn how to get the most out of them and use them really carefully. Try and think about the ethics. Try and think about the way that they actually make the decisions that they do. And back to the mold point, that they might not actually be making any decisions at all. They're just doing exactly what we've trained them to do. So look at AI as that sort of partner to your future career, no matter what industry you actually end up working in. Thank you.